Well, greetings, Mr. Colazar's class. We're going to continue now looking at the idea of phase changes. When we talk about phase changes, we're going to look at the energy added or removed to cause the phase change to go from one state of matter to another. So a phase change, think of it as a change of the state of matter. I guess we could say change. State of matter. So we're going to look at addition and removal of energy to cause this, and we're going to look at interpreting a phase diagram. So our first one, we're going to look at a phase diagram. We're going to look at what we're going to call just our heating curves. And a couple of things we want to look at is as we continue to add heat, how does the temperature change of our material? And notice it's going to have A, solid, B, solid to liquid, liquid, liquid to a gas, and then finally just a gas. So if we start up with a substance that's a solid, notice as we add heat, the temperature goes up. Once we get to this point, though, from here to here, at point B, solid and a liquid are happening. This is going to be where we're going to be changing our state of matter. So we're changing the state. And when we change the state of matter, that's going to be where temperature is constant. We're not changing temperature. So changing the state, no temp change occurs during the change of state. So that's key. No temp changing. That's our first idea. And our second idea is going to be, reason why is we're breaking and changing those IMFs during this time. So those intermolecular forces, we're using that energy to break those, causing our change in state. Now, once they're all broken and we're at a liquid, notice that our temperature can now increase once we're a liquid. So after we're a liquid, temperature can continue to rise as heat's added till we get to the point when vaporization, going from a liquid to a gas, can occur. And once again, we're changing state. And as we change the state of matter, we're breaking those IMFs, and it's causing us to go from a liquid to a gas. And again, once we get all of the liquid gone and it's all just a gas, then we can change the temperature again. So as we add heat or energy, if we're changing states, the temperature stays constant until the entire state changes went. So that's kind of our idea with the heating curves as we add more heat or energy to the system. A phase change. Phase change, matter going from one state of matter to another. So we have 6 common phase changes. And our phase changes occur when energy is either added or removed. So we can either add energy or remove energy to have this happen. We need to know this chart. I guess we could call it a diagram. Let's call it a diagram. So we need to know this diagram. Most of these you already know. Melting and freezing as we go from a liquid to a solid or solid to a liquid. Condensation and vaporization, gas to a liquid, liquid to a gas. 2 that we have to remember a little bit more, sublimation, solid to a gas, and then to make that gas to a solid, deposition. So most common example for that one, remember, is dry ice. So as we look at our phase diagrams, the first 3 phase diagrams require energy. So we need to think about it from in terms of the substance. So our first one's melting, solid to a liquid. So go from a solid to a liquid, we need to have heat added to the material. To go from a liquid to a gas, vaporization, you need to add heat. And then to go from a solid to a gas, sublimation, we need to add heat. So all 3 of these require energy to be added into it. So require energy or add heat or energy. Now the other ones release energy. Now remember, we don't add cold, we remove heat. And as we remove heat or energy, our other 3, freezing, liquid to a solid, Condensation, gas to a liquid, or deposition, gas to a solid. These three were all removing heat. So you need to make sure that you know this diagram. So adding and removing heat to change the state of matter we're in. And then just a couple ideas with changing state of matter is vaporization and evaporation. So these are the two, liquid to gas. And as you go from a liquid to a gas, evaporation occurs when only the, or excuse me, evaporation occurs, or vaporization, excuse me, only occurs at the surface of the liquid. And evaporation occurs at a temperature lower than the boiling point. So as it's lower than the boiling point, say water below 70 degrees, some of the water is going to evaporate into the air, but overall we've got air pressure pushing down, and as that air pressure pushes down, most of the material stays as a liquid. At the boiling point, that temperature is risen, and at the boiling point, more of our substance, since that extra energy is added, can be pushed and break that pressure from the atmosphere. So vapor pressure is the particles of the surface pressing down, exert a force or pressure on the gas. At the boiling point, the temperature at which the vapor pressure of the liquid equals the external atmospheric pressure. So that's what actually causes our liquid to boil, and we can see our boiling once it's raised to a temperature that's equal to or greater than the air pushing down. So the difference between boiling and evaporation, boiling happens at the boiling point, evaporation happens below the boiling point. And that goes through our phase changes, making sure that we know that phase diagram.